Hello, geometry students. So here we are back. Today I'm going to be going through 10.4. So if you want to follow along, the first slide here we have is a warm-up. And if you want to just pause the video for a second and give the warm-up a try, and then we'll start back up here in a little bit. So the question is to find the measure of the arc or chord in circle Q. So pause your video, give it a try, and then we'll start back up and I'll go over the solutions. Okay, welcome back. So we have here, it looks like a quadrilateral inscribed inside this circle. And first we're asked to find the measure of arc WX. That's this arc right here. And so in order to find the measure of that arc, I would need to know the measure of its central angle here. If I look, the angle directly across from it, or its vertical angle, is 42, which means the measure of this angle here would also be 42. So I'm going to write that down. Let me get my pen. All right, so this arc here would be 42. And if that if that angle is 42 degrees, then so is this arc out here. So central angles have the same measure as their intercepted arc. So I'll write that over here. Maybe. Okay, so number one, we have 42 degrees. Then on number two, we are asked to find the length of YZ. So YZ is talking about the side of that quadrilateral. So it's talking about this length right here. So it looks like, let's first of all talk about some things. So I have this segment here, WY, which looks like a diameter. And I have XZ, which looks like a diameter. And diameters have to be congruent in the same circle. So if these diameters are congruent, then that means WXYZ is a rectangle. And if it's a rectangle, then the opposite sides are going to be congruent. So to figure out the side ZY, I would just look across and say, well, it's got to be the same as WX. And so it would also have to be 3.6. Okay, similarly, if I'm trying to find the length of WZ, this side of the rectangle would have to be the same as its opposite side. And so WZ would also have to be 9.2. Okay, lastly, we're looking at the measure of arc XY. So again, this is a diameter. We already know this much of the semicircle here. Remember, semicircles are 180 degrees. That was from section 10.2. So if we have that arc WXY is 180 degrees and WX is 42, then to figure out the measure of arc XY, I would do 180 minus 42, which should be 138 degrees. All right. Next slide. So today we're going to be talking about inscribed angles as opposed to central angles that we had in section 10.2. So hopefully you already copied this down from the student journal. If not, go ahead and pause the video, copy down these vocabulary terms on page 295 in your student journal. All right, so an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So this time, notice the vertex is not in the center, but is on the circle itself. And then here's a side, and if you look, here's a chord in the circle. If I go just from this point to this point, the other side of the angle goes from this point to this point, another chord. And then the intercepted arc is the arc that lies between those two sides of the angle, or between two lines, rays, or segments. We can inscribe a polygon. That means it's a polygon whose vertices all lie on a circle, right? So if I look, it's like inside. I can circumscribe, that means to go around. I can go around a polygon, right? All the vertices of the polygon are on the circle. We say the circle is circumscribed around the polygon and that the polygon is inscribed. You might come across this word subtend in this section. It says if the endpoints of a chord or arc lie on the sides of an inscribed angle, the chord or arc is said to subtend the angle. You just might come across that word. It's good to know. All right, we have some theorems in this section. The first says the measure of an inscribed angle theorem. And it says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So if you remember in section 10.2, a central angle had the same measure of its arc. Now, if we have an inscribed angle, it is 1/2 the measure of its intercepted arc. So this angle ADB is 1/2 of arc AB. Inscribed angles of a circle theorem is our next theorem. It says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if I look, angle ADB here intercepts arc AB. I also have angle ACB. It also has an intercepted arc AB. Since they both have the same intercepted arc, that means the two angles ADB and ACB have to be congruent to each other. If we have a right triangle inscribed in a circle, and the only way you can do it is to put it in a circle, have all vertices on the circle. If you have that case, if you can get a right triangle inside a circle, then the hypotenuse of that right triangle has to be the diameter of the circle. So it says the measure of angle ABC equals 90 if and only if AC is a diameter of a circle. So it's the only way you can fit a right triangle inscribed in a circle. We can inscribe a quadrilateral. If we have a quadrilateral inscribed a circle, then the opposite angles are supplementary. So let's jump to some extra practice. This starts on page, looks like 297. So our first one, it says, find the measure of angle A. Well, let's look at this here right now. I see I have a diameter. I have a triangle inscribed in the circle. I can see that I have this longest side of the triangle is a diameter. So that means that I know that triangle BAC has to be a right triangle. So if it's a right triangle, here's the diameter, which is the hypotenuse. Opposite the hypotenuse is always the right angle. So the measure of angle A has to be 90 degrees. Okay, next we're asked to find the measure of angle C. So remember again, we're talking about inscribed angles today. So let's look at some things first before we try to figure out C. So today it's inscribed angles, not central angles. So if I look this angle right here, angle ABC, it says is 28 degrees. So if the inscribed angle is 28, its intercepted arc is double that, right? Remember in 10.2, the central angle was the same. This time the inscribed angle is half the arc. So that means this arc up here, arc AC, has to be 2 times 28, which is 56 degrees. And I'll just put that right here. Now it helps me if I want to figure out the measure of angle C. Again, I have a diameter, which means this entire arc here would have to be 180 degrees, right? It's a semicircle. So to figure out the measure of angle C, I can use the fact that I know this entire arc is 180. I can subtract 56 from it to figure out AB. So I'm going to do that. I'm going to do 180 minus 56. And that means this arc right here has to be 124 degrees. So I'll write that down. So if this arc here, going from A to B is 124 degrees, then angle C, and let's see if I can extend these sides and you can see where angle C is. So here's one side. Here's the other side of angle C. I'll put some little arrows on the end. All right, so angle C is actually this angle here, ACB. So to figure out that, if I look, it intercepts this 124 degree arc, which means this angle is half that measure. and half of 124 is 62 degrees. So the measure of angle C is 62. Right, next we're asked to find the length of segment BC. So BC again is the hypotenuse of this right triangle. Since it's a right triangle and I know two sides, I can use the Pythagorean theorem to figure out its length. So to figure out BC, I'm going to do 3.9 squared plus 7.3 squared equals BC squared. All right, so I'm going to do those calculations. I have 3.9 squared plus 7.3 squared. So that gives me 68.5. And that's equal to BC squared. So then BC is going to be the square root of 68.5. And I get that BC is about 8.3. All right, next we're asked to find the measure of arc AC, but if you look, we already found that when we were trying to figure out the other arcs. So the measure of arc AC, I can get my pen to work. Measure of arc AC then would be 56 degrees. We already found that. And last, the measure of arc AB, we also found earlier already. They were kind of tricky putting these in different order to make it confusing. Come on, pen. Don't know why it doesn't want to go down there. There we go. So arc AB we have is 124 degrees. All right, let's look at the next slide. This time it's asking us to name two pairs of congruent angles. So remember, angles inside a circle are congruent if they intercept the same arc. So I can look here. Let's get my pen. And I can look, let's see. I have this angle here. If I look at angle ABD, it intercepts this arc AD here. The other angle that would intercept that arc would be angle ACD. If you look, they both intercept this arc right here, arc AD. All right, so one pair of congruent angles would be angle ABD, and that's congruent to angle, looks like DCA. All right, we're supposed to find another pair, so I'm going to switch colors here. Okay, so this time it looks like I have this arc here at the bottom of the circle. I could look at this arc right here because I can see a couple of angles that intercept that arc. So it's arc BC. So if I look, if I extend the sides here of this angle, that certainly intercepts that arc. And the other one that crosses it would be this angle right here. It's getting kind of messy, sorry. So the other pair of congruent angles would be angle BAC is congruent to angle CDB, because both of them intercept arc BC. All right, our next question. we're asked to find the value of each variable. So if I notice, this figure inside here is 1, 2, 3, 4 sides. It's a quadrilateral. We had a theorem that said if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So this time I look at opposite angles. This one's an easy one to figure out. Supplementary means that the angles add up to 180 degrees. So I can say that n is equal to 80, right? And then I can also look here, 180 minus 65. Remember, again, supplementary angles add up to 180. So 180, 65 leaves me with m is equal to 115. Okay. Next slide is your assignment. Again, this is the assignment if you don't have access to Schoology. The same problems from this assignment are in Schoology. They're in a multiple choice format. You get 3 tries to find the answers, check your solutions, and that's it. All right, thanks for joining me. Again, I'll be available Monday through Friday from 10 to 2 to answer questions. See you guys there.